Kerberoasting is the most famous authentication in the world. So it is being widely used. And if you are using a Windows device to log into your organization, then it's most likely that you're being authenticated using the Kerberos authentication. And if you look into the Kerberos authentication, by design, there are a few flaws associated with this. And hackers, noting those flaws, they have exploited them. And in some cases, they have also gained a full admin privileged access to your domain. And in one such flaw which is being exploited is called Kerberoasting. The Kerberoasting main goal is to get the password hash of a service account in your network. So in general, people used to give a full admin privileges to the account. Therefore, they don't have the headache of maintaining it, right? But providing an admin privilege to a network is not a recommended thing. It's not a safe thing to. And in the curb roasting attack, that's what hackers will also be expecting. That if at all a service account has admin privilege, then hackers are happy. They can just get into your domain with the full admin privileges. So if you talk about curb roasting is actually a post-exploitation method. So if you want to perform a curb roasting attack, then you will need to have a domain user in place. The user need not to have admin privileges or any kind of privileged access. It's just a domain user will suffice, will do the job. This is what the curb roasting. And in today's session, we can see what is it. So I'll first show you the practical demonstration on how to perform curb roasting and one of the ways, because there are like a lot of ways, a lot of tools. And I'll explain one of the ways, practically explain it. And also I'll let you know that I'll also let you know the theoretical part that is happening behind the Kerberos attack. This is my, I hope my screen is visible. Yeah, this is my Kali Linux. So you can consider this Kali Linux to be an attacker's machine from which we will be trying to access a domain controller. So I also have created a sample or an example domain controller for this setup. I'll quickly share you the screen of that domain controller. This is the domain controller that is in place. And I have created a few uses, particularly this Tor. So I'll be most focusing on this Tor because in my case, I consider that I've somehow gained the Tor credentials. So let's say I've sent a phishing email and Tor fall for it, and he has provided a password in the phishing attack. So somehow by phishing attack or let's say brute force attack, so whichever attack I performed, and I somehow gained the Tor's credentials. So if you look at the Tor's credentials, you can see that Tor is just a normal domain user and he doesn't have any kind of fancy privileges. So if you can see, he's just a domain user and no fancy privileges associated with it. The domain controller, and we don't have much to do with the domain controller because we are hackers in this scenario. And I'll let you know what it all has to be done from the Kali Linux. This is my machine. This is my attacker's machine. You can consider it. So with this machine, I'll be trying to perform the curb roasting attack on the domain controller, which I just showed you just now. So here the main focus for me will be to get the service principal names of the service account, because curb roasting is what? To get the secret key or the passwords of the service accounts, right? So in domain controllers, usually all the service accounts will have something called SPNs, service principal name, and these service principal name is kind of like their full name, and this is used in the Kerberos. Therefore, even we will be utilizing the same SPNs to get the information of the services. So to proceed with this attack, I'll be utilizing a tool called IM Packet. So this IM Packet is one of the many tools that is available in the market. Why I'm using is that I have Kali Linux, and in Kali Linux it's already inbuilt. So I'm just going to utilize it. If you want, you can install it in your instance. If not, you can utilize any such tool for the curb roasting attack. Also, if you are well familiar with PowerShell, you can always go ahead and perform the attack from the PowerShell as well. So yeah, so enough of talking. So let's get into it. So I'll just open my terminal. Let me increase the size of the font so that it would be better. And yeah, yeah. Okay. So now I'm going to, yeah, so as I mentioned, I'm going to utilize the IM package. So I'll just utilize IM package. So as I've already run this command, it's already showing up. I'll explain you each of the things. So first, the IM package. So this is the packet. This is the tool that we are going to utilize. And here we have the module. So here, as I mentioned, all the service accounts will have SPN, service principal name, and the Kerberos will utilize the service principal name to associate with the services. Therefore, even we need service principal names, and with the service principal names, we will be extracting the hash values. In fact, I'll be utilizing the module so gets user SPNs, and this is my domain name, so loghistory.com. So this is the domain name, and as we saw in the domain controller, this is the user whose credentials I have acquired using phishing attack, which is Tor, and his password that I acquired is adminet123, a basic password. And then we have the we'll have to provide the IP address of the domain controller so that the IM packet can focus on the domain controller. So when I just provide the IP and enter, it will collect the it will collect and display all the services that are available in the domain. So here you can see that there are two services that are available at the moment. So which is the test service and SQL. So in our instance, I'm more focused on the SQL. So I'll be looking for a hash value for the SQL service. So to get the hash value, so to perform the Kerberoasting, it's very simple with this tool. I'll just run the same command. With this, I'll include the argument request. So when I include the argument request, it will request for all the hash value that are available for the service accounts, and it will display. So since we have two service accounts, we have two hash values. One is the test service hash value, which is M service. If I can see, this is the first hash is for the M service, and the second hash is for the SQL service. And since I'm looking for the SQL service, I'll be taking this hash value. So what I'll do is I'll just copy this hash value and paste it in somewhere else. So this is actually Kerberoasting. So the method is to acquire the hash value. So once I acquired it, now I'll just take it to the offline. So since it's now I have the hash value, I'll put it in some once again, I'll put it in some tool. I'll put it in a text document such as let's say secret.hash. Once I did it, now I have the hash value. Now the only remaining thing is to start brute forcing and get the actual password of the service account, which is here a SQL service. So to do that, there are multiple tools again available. I'll be utilizing the John the Ripper, but also there is a famous hashtag cat tools and other such tools. So whichever you like, you can proceed with it. So I'll put John the hash secret hash John space the file name and enter. Now it will go through the hash and it will put down the password. So since the password is something very easy, password with 0 instead of O, it has simply got the password. So since it's being a very commonly used password, the John the Ripper has extracted the password in seconds. And voila, now we got the service account password. The Kerberoasting attack is successfully completed. So see how easy it is, right, to perform the service account, to perform the Kerberoasting. So the only main requirement of for the Kerberoasting is to have a domain use. So if you have a domain user, then you can perform the Kerberoasting attack. So this is the practical way of doing it. So I'll let you know what exactly happens behind the scenes. So now we'll go through the actual theoretical part, like what exactly happens during all this Kerberoasting attack. Okay. So to understand this, I highly recommend you to see my previous video where I have explained about the entire process of the Kerberos authentication. So only when you understand the Kerberos authentication, you will be understanding the actual backend mechanism of the Kerberoasting attack. Okay. So if you take the Kerberos authentication, so the first step would be the client will send a request to the authentication server, and the second step will be authentication server will be sending a couple of packets, in which one packet would be this secret key, this packet. Once we receive this packet, we will create new two packets. So we will know the TGS server location, and we will create two new packets along with the third packet, and I'm going to forward it to the TGS. So while forwarding this to the TGS, I'll before even the authentication, I'll just do one. I did one few tweak, which is I've requested the KDC, which is Key Distributed Center. So basically, the Key Distributed Center is the part where the authentication server and TGS are hosted. Again, if you don't know, please see my previous video. So I will request the KDC to communicate in the RC4 encryption method. So with this method, what happens is that uh, the brute forcing, or to gain, to know, or to decrypt, let's say, it will be much easier rather than using some standard encryption mechanisms such as AES, advanced encryption standards. If you use advanced encryption standard to encrypt your packets, it's not like impossible, but it's very difficult rather than using the RC4 encryption method. So therefore, while we perform the curb roasting, we will ask the Kerberos to communicate using this RC4 encryption, so that it will be beneficial for us. But why does even Kerberos allow this? Because um, if it's an vulnerable one, or if it's an easy crackable one, why it's still available? It is because due to the backward compatibility. So because of this constraint, they haven't removed this encryption yet, and this is being enabled by default, which is even better for the hackers to perform. Okay, coming back to the slide. So now the client in the third step will send these packets to the TGS, and as I said, it will have the RC4 encryption. And now again, the TGS will, since the TGS will knows its own secret key, it will decrypt the third packet, and it will get the session key. With this session key, it will decrypt this second packet. And once decrypt, it will check if there is if both the usernames are equal. If it's equal, then it's the username is validated, and it will create two more tokens. So the first token is the information of the service name and service session key, and it is decrypted with the TJ session key, which the client already have. The second token, this is where our interest lies in the curb roasting. Here, the same details will be available with the username, but this is encrypted for the service account. So this particular packet is for service account and not for the client. So therefore, the service account can decrypt using its password and check if the username is the same as the one that who has requested for. And when this sent to the client, once he receives, now at this time, our tool execution, that the IM packet that we discussed, that we saw earlier, right? The execution will stop, because moving forward is again useless. We don't have access to SQL, right? And it will display the hash key that it has received from this. This is how we can see the hash value in the console once we once we ran the tool. Once we received, what I did, I just copy pasted that hash value in an text file, right? So once I copy pasted in the file, then I've kept it ready. So so now it comes to the offline tracking, where I have the password ready in hand. And now I use the tools such as Hashcat or John the Ripper, and I'll start to guess the password or decrypt the password. So John the Ripper will go through all the commonly used password that it has, and it will check the hash values of those with this. If anything gets matched, and it will let us know the password, and the password will be displayed in the console. By this, we will get the actual password of the service account. So this is the actual backend mechanism that is running in the Kerberoasting attack. So this is the overview or in-depth discussion on the Kerberoasting. Now let's see how can we prevent this Kerberoasting from happening. So we know how it works, what are the tools that are being used. So it's important to know, right? The first and foremost, we should use a very strong password. The password should be at least 12 or 16 characters in length, and it should be in the different characters, like special characters must be used. And again, so since the entire or most of the curb roasting attacks utilize the RC4 encryption, it's always advisable to disable the RC4 encryption. Therefore, it will become even much difficult for the hackers to get the password and decrypt it with it. And again, you don't have to provide a complete admin privilege to the service account. So if you provide a limited privilege, least privilege to the service account, then again that would be even much better. If not, you can straight up utilize the group managed service accounts. So this GMSA, if you use these service accounts, the password will be automatically managed by the Windows devices itself. And when you use these accounts, there will be no RC4 will be used. The default encryption method will be AES, and that's what it will be used. So you can utilize the GMSA methods, and the possibility of co-browsing will become much low. And despite all the prevention, it is always advised to utilize a SIM solution and well-validated SIM solution to monitor your organization. So if at all anyone tries to perform curb roasting, the SIM solution will help you to detect it and alert you that there is an ongoing curb roast attack in your organization. So by this, you can always have a very good defense mechanism against attacks such as curb roasting. Yeah, so that's the end of the session. So thank you so much. And if you have any queries, you can let me know in the comment section. And yeah, see you soon. Bye bye.